All right, ladies and gentlemen, today we're going to be talking about vector component form and magnitude. So there are many physical qualities, like speed, that can be completely described by a single real number called a scalar. Okay, so let me just make sure. A scalar. Okay, this number indicates the magnitude or size of the quantity. In other words, how fast someone's going or how hard you're moving. Okay, a vector is a quantity that has both magnitude and direction. Okay. So then the velocity of a football is a vector that describes both the speed and the direction of the ball. So in other words, let's say player A kicks it over to player B. All right? So then it goes that way. A is called the initial point or the tail. And then B is called the terminal point or the tip. Okay? So obviously the little arrow, that's the tip. And then as you go over here, the beginning, it's the initial or the tail of the movement. Okay? So that's important. These over here are all vectors. You can move in many different directions. And you can give them angles and speed. See, notice how the football is kicked. Let me use a different color so it's easier to see. Let's do bright red. So the football starts here and then is kicked that way. So let's say it's moving at 17 miles per hour. That's the scalar. And then we have 35 degrees on this side, and on this side we have 55 degrees. So another way to say this would be north 55 degrees east. Okay, that's one way to say that. Now, here are some describers. We have parallel vectors, equivalent vectors, and opposite vectors. So parallel vectors are ones that are moving in the same direction and will never ever touch. Okay, so I'll highlight those in red. So you have like A and B and C and E and F. All of these, so A, B, C, E, and F, all of these are never going to touch because they're moving in the exact same direction. Okay. All right, equivalent vectors, I'll do those in blue. Okay, equivalent vectors are the ones that have the same angle and magnitude. So for example, A and C have equivalent vectors. In other words, A equals B. Okay? And then finally, opposite vectors, I'll do those in green. Opposite vectors have the same angle, the same size, but they have different directions. So that will be a little bit trickier to show you, but check it out. Okay, so in green, think of, let's say, A and E. So this one and this one. Okay, E and A. All right, which one else? E and C. E and C are opposite, so E and C. Okay, now another way to write this, okay, let me explain real quick, would be A and the opposite of E, and then C, oh sorry, these equal each other. So if I were to get the opposite of E, that would equal A. If I get the opposite of E, that equals C. Okay, so right there, opposite vectors. So I highly recommend you write this on your notes. Parallel vectors are the ones that have the exact same angle, meaning they go in the exact same direction. Equivalent vectors have same angle and magnitude. In other words, the length of it is exactly the same. And then finally, opposite vectors have the same angle and size, or in other words, magnitude, but they have a different direction. Okay? So now let's get an example on this next part right here. Alrighty, so a vector written in component form, which is right here, so this is how you want to write it. I'll do it in red right here. Okay, the triangle brackets, A comma B, can be found by subtracting the initial point, which is the tail, and the terminal point, which is the head. All right, now this one has a name. It's called vector, and here's how you write a vector. A, B. Okay, this is A, B with a little arrow. So that means you will connect A and B, and then draw an arrow at the end. Okay, so there we have drawn the vector. Now, if an arrow has initial point x1, comma y1, and terminal point x2, comma x2, then it can be represented as a vector like this. Okay, it looks scary, but really you're just subtracting. So now let's actually get the value of the vector. So this one right here, if we go back 5 units, and this one goes up 3 units, this is -5, comma 3. This is your x1, y1. Right? And then this one goes 1, 2, and then up 1. So this is 2, comma 1. This is your x2, y2. Okay. Now, if we want to get what's it called? The number of the vector. Okay. So now a, b, the vector. Okay. If I want to get its component form, well, that equals, like we said up top, your x2 minus x1, comma y2 minus y1. And we know those values. They're over here on the graph. So this would be, it's ugly, x2, which is 2, minus -5, comma, and then it's y2, so 1 minus 3. And I'll highlight these in color. So in blue is my x's, so x1 and y1. And then in red are my y's, so the 1 and the 3. Now, quick math, 2 minus -5, that's just 2 plus 5. So I get 7, comma, 1 minus 3 is -2. And that is the vector form, or component form, of this vector. Okay? This means it goes right 7, down 2. Okay? Now, to get the magnitude, this is the symbol you want to use for magnitude. It would be A, B, with those bars next to it, like double bars on both sides. That just means the length. So I'll do this in purple. That means the length of the line. Okay? And if you notice, this is a triangle right here. So I'm going to zoom in for a second. This is a triangle. And I can figure out the length of that using the Pythagorean theorem. A and B, and this is letter C. So a squared plus b squared equals c squared. So a squared plus b squared equals c squared. We know how to do that. So the formula for this, okay, if we want to figure out c squared, so I write it again, a squared plus b squared equals c squared. Well, then I just have to square root both sides. So it would be the square root of a squared plus b squared equals c. So, and check it out. Here's your, I'll do it in red. Here's your a and here's your b, but make sure it's the negative version right here. So here's a and here's b. So then what you need to do is you will take the square root of a squared plus b squared, or in other words, the square root of 7 squared plus -2 squared. Now you can use your mental math. What's 7 squared? That's 49. And -2 squared is 4. So then square root of 53. And that is the magnitude. That is the magnitude of this line. Okay, the square root of 53. And that's it. That's all you got to do. Okay? And so here's something you want to write down, okay? So all equivalent vectors. So all equivalent vectors would go right 7 and down 2 on the graph. That's something that you need to know. So if I found an equivalent vector that say from here to here, well, that would go down 2 over 7. And so that vector would look exactly the same. It'd be equivalent, okay? All right, so let's try an example on the next page. So then, find the following information for each vector, component form and magnitude. Well, we can give this a little quick graph, but we don't really have to. We just have to do the component form. This is x1, y1, x2, y2. Okay, so then what we're going to do is do component form. So A, B with an arrow, that is triangular bracket. All right, so it's going to be, like we said, x2 minus x1, comma, y2 minus y1, close bracket. So now let's do those components. So my x2 is right here, and my x1 is right here. So it will be 6 minus negative 10. And then now we do the other one. So here it is in pink, y2. And then let's do green. There you go, Cosmo and Wanda. So that would be negative 3 minus negative 8. Now just compute. So 6 minus negative 10, that's just 6 plus 10. This is negative 3 plus 8. Quick math, this is 16, comma, 5. And so there is our component form of the vector. That is one half of the answer. Now the other half is where you do magnitude. Now make sure you write out the whole phrase. So A, B with the vector on top, and you do the double bars on both sides. That's how you get magnitude. Now remember the formula. This is A and this is B. So this is the square root of A squared plus B squared. So this would be the square root of 16 squared plus 5 squared. And now all you got to do is figure out 16 squared. If you have a calculator, you can use it. So this would be the square root of 256 plus 25. And so you do that quick little answer, square root of 281. And if you have a calculator, you could calculate this. So the square root of 281, okay, so A, B, vector, the magnitude is 16.76305. And that would be the answer. Okay, so if you have a calculator, this gets really easy, really fast. Okay, so that's it. Like I said before, you don't have to do these. You will do UT Quest later, okay, and during class. So have a wonderful day, and I'll see you later.